Hello again, and welcome to another video tutorial. In this session we will be talking about how to design and construct an IoT health monitoring project using LoRa technology, ESP32 and Arduino. This project would be made to be wearable such that it can be placed on a user's arm to measure and monitor health parameters like the heartbeat or pulse rate, the body temperature and skin humidity. We will of course be sending these to a Blink IoT dashboard for remote viewing. The cool part of this project is that it uses the LoRa technology to transmit these data over long distance. Which means the project design is of two parts, the sender and the receiving part. Let us get into how this project was designed and built. For the complete bill of materials used for this project design, see the link in the description below. Now, let us jump into the schematic diagram and its explanation. For the project is made up of two parts, the transmitter side also known as the sender and the receiving side also called the receiver. The transmitter has the ESP32 board that controlling the sensors lit the DHD11 that is responsible for the body temperature and skin humidity reading. Whereas the pulse rate sensor takes the heartbeat readings on the user. Now these readings are sent through the LoRa SX1278 module. We also connected an OLED screen to show the user the health parameters too. And all of these are powered by a rechargeable 3.7 volts battery. The schematic diagram here doesn't do it justice due to fritzing. The circuit IDE doesn't have a picture symbol for a 3.7 volts battery. The receiver side is made up of the Arduino Nano board that is connected with the same LoRa transceiver module. We wired it in such a way that it allows us to connect an LCD screen to display the received data from the transmitter side. This part is also powered by a rechargeable battery system allowing the both system designs to run and keep running even when there is no external power source connected to it. As you can see, we attached a 3.7 volts charging module to recharge the battery on the go. This receiver design is kept with a health professional who monitors the health readings of the user. And a buzzer is connected to this design to notify the healthcare assistant of the possible dangerous readings that may be received. Now, let us assemble the components according to the schematic design. First we begin with pulse rate sensor and we place this at the bottom of the enclosure. Since we intend to make this project design wearable, we will attach a Velcro handle to it so that it can easily fit onto and around the wrist of the user. We glued this heartbeat sensor to the encasing and proceeded to connecting the digital temperature and humidity sensor that will read the body temperature and skin humidity. Most of these attached are easy to do once you have a portable glue gun that can easily melt and hold stuffs together. The heartbeat sensor is made to expose at the other side as shown here. All the wires to these sensors would of course be connected to the ESP32 development board soon. Of course each of these design would need a power switch to turn them on and off at will. Hence we are using the red round button switch for this. It will allow the supply of power from the backup battery to the rest of the modules in the circuitry. And each of this design comes with its own charging module to keep the rechargeable battery charging at will. This means we can choose to use an external power supply or the backup battery power supply. We built our own permanent circuit board using a Vera board and other peripheral components soldered onto it. It allowed us to connect the modules like the ESP32 board easily and also remove it when we want to troubleshoot the hardware design. Here is an image of both the transmitter part of the project design alongside its receiver part. With everything coming in place, we have to proceed to programming the project design. Now, let us explain programming the project design. You can grab a free copy of the Arduino code used for this project design by following the link in the description below. The codes are of two parts, one for the receiver and the other for the sender. We tried to use comment lines to explain what each line of code does. However, the code uses some of the libraries that are needed by the modules themselves. For the OLED screen, we had to import the OLED library before we can display anything on the OLED screen on the transmitter side. Also, the DHT11 sensor uses a special library to call the functions that read the temperature and humidity of the vicinity it is in on the transmitter side. The receiver, on the other hand, needed the LCD library to display the received data from the transmitter. It also needed the LoRa library to communicate it with the other LoRa transceiver module at the transmitter side. Once you download these Arduino source codes from the link in the description, install the NIDA library and connect your project as shown here in this video, then upload the code. Once you upload the code, everything should be working as expected. However, you can also make some minor adjustments if you need to. Now, let us proceed to testing the project design. To test the project design means we have to wear the project on a user's wrist. Also, we want to test for extreme or adverse conditions when the user is having some high heartbeat. But that would mean that we had to induce it. To take care of this, we added two buttons on the transmitter side to check for two adverse states of the pulse rates. When it is too low and when it is too high. This way, when any of these buttons are pressed, the receiver gets this adverse reading data, and the buzzer will start to sound. And the health professional will know that something is wrong. All of these were tested and they are worked very well. The project design was able to send the data measured from the transmitter side to the receiver side without any problem, and it doesn't incur internet expenses and can transmit and receive this data packets over distances as far as 10 kilometers. And that is it. We have successfully completed the project design. I hope you liked the project design. Please, like, share and subscribe for future videos. Thank you for watching.